Hello everyone, so in this video we will be discussing operations in polynomials. So operations in polynomials basically deals with how we perform the addition, subtraction, multiplication, and division of a polynomials. So for the first discussion, we will be discussing addition and subtraction of polynomials. So we have here an example: add the polynomials x squared y minus 2xy plus 9y squared. And we also have 7y squared minus xy plus x squared y, and the same as 2xy plus 3x squared y minus 5y squared. And we also have the last one, which is 4y squared minus 4x squared y plus 3xy. So the first thing that we need to do here is to rearrange our algebraic expressions and combining the like terms. So we have here, for the first one, we'll copy the format of how the first algebraic expression is written. So we have x squared y minus 2xy plus 9y squared. Now we also have another algebraic expression which is 7y squared minus xy plus x squared y. So basically you just have to rearrange or to align the like terms, since this is x squared y, so meaning to say we'll rearrange the algebraic expression and having our x squared y being the first one written. Now we also have the minus xy, since xy has the same term with the middle term, so we need to write it here. And the same as our 7y squared, since this line here is for y squared, so we'll also have to put there our 7y squared. The same process as the other polynomials that we have. So we have 2x, this is our 3x squared y. So we also rewrite that one there. Our 2xy will be written here. And we also have our minus 5y squared. And we also have the negative 4x squared y plus 3xy. And the last one is our plus 4y squared. This is plus. Now, we need to perform the addition for all of these algebraic expressions. So, let's start following the same format as how we perform addition with constant numbers. We'll also start from the right. So 9 plus 7, that is 16, minus 5, that is 11, plus 4, that is 15. So meaning to say we have 15y squared. Since they has the same term, or they has the same base and exponent, so you just have to copy that one. Now for the middle term, we have negative 2 plus negative 1. As we know, this is an imaginary value of 1. So meaning to say we have negative 2 plus negative 1, that is negative 3, plus positive 2, that is negative 1, plus positive 3, that is positive 2xy. Positive. Then for the last one, we have x squared y plus x squared y, so we have 2x squared y, plus 3x squared y, so we have 5x squared y, minus plus negative 4x squared y, so we have 1x squared y. So this is now our final answer. So our final answer is equivalent to x squared y plus 2xy plus 15y squared. So that is how we perform addition, or how we add polynomials. Now let's move on to subtraction of polynomials. So in this case, we have here an example. Subtract 4a cubed minus 8a squared b plus 7ab squared minus 12b cubed from the sum of 8a cubed minus 2a squared b plus 10ab squared plus 2b cubed and 3a cubed minus 2a squared b minus 3ab squared plus 22b cubed. So basically, we need to find first the sum of these algebraic expressions. before we can perform the subtraction of this one. So first, let's do that one. So we have, we'll rewrite this one. We have 8a cubed minus 2a squared b plus 10ab squared plus our 2b cubed. And then it is said to add by 3a cubed. So we have 3a cubed minus 2a squared b. So it's the same. For this one, we have 3ab squared. So we have, this should be minus 3ab squared. And we also have the last term, which is 22b cubed. Now, adding all of this, we have 2 plus 22, that is 24b cubed. We have 10 plus negative 3, that is positive 7ab squared. And then we have this one, negative 2 plus negative 2, that is positive, or that is negative 4a squared b. And then for the last one, we have 8 plus 3, that is 11. So we have 11a cubed. Now we already got the sum of the two polynomials. Now what we need to do is we need to subtract this one. We need to subtract this algebraic expression from the sum. So meaning to say, from that we can already subtract this. 4a cubed minus 8a squared b plus 7ab squared. Then we also have minus 12b cubed. So performing the subtraction, we have 24 minus negative 12. So we have positive 36b cubed. We have 7 minus 7, so that's basically 0. And we have negative 4 minus negative 8, so we have positive 4a squared b. For this one, 11 minus 4, that is 7. And copy the base and the exponent. So basically, this is now our final answer. Although you can opt to not write this one, the 0, you can just leave it as blank. And then you have to move this together or closer with the other terms. So that gives us the final answer, 7a cubed plus 4a squared b plus 36b cubed. So this is now our final answer. So now we'll move on to the discussion of the multiplication and division of polynomials. So we have here the example, find the product of 5x squared plus 4 minus 2x and 2x plus 3x squared plus 2. So basically, we'll just have to rewrite this one inside the parenthesis. Our multiplicand is 5x squared plus 4 minus 2x multiplied by 2x plus 3x squared plus 2. Now basically there's a lot of process on how we solve or how we perform multiplication of our polynomials or algebraic expressions. However, it will be up to you on which operations or in which in which process you are comfortable using to solve the multiplication of polynomials. But for me, I will be using distributive property for this example. So that means I will be distributing 5x squared, or this first term, to each term of our multiplier, and following the same process with the other terms here. So now let's try to perform the multiplication of this one. So we have 5x squared multiplied by 2x, that is equivalent to 10x cubed. Now 5x squared multiplied by 3x squared, that is equivalent to 15x to the fourth. 5x squared multiplied by positive 2, that is equivalent to 10x squared. Now repeating the same process with the other terms, so we have 4 multiplied by 2x, that is positive 8x. 4 multiplied by positive 3x squared, so we have positive 12x squared. And we have 4 multiplied by 2, that is positive 8. Now continuing the same process with the last term, so we have negative 2x times 2x, that is negative 4x squared. Now you really have to be careful with the exponent, class, because once you forgot the exponent of this one, it is very confusing now to track or to trace where what term you have gone, how you have solved it wrong. So you just really have to be careful, especially with the exponents. Now, continuing, we have negative 2x multiplied by positive 3x squared. So we have negative 6x cubed. And we also have negative 2x multiplied by 2, that is negative 4x. So now we will just technically, this is already the product of our polynomials here. However, we need to simplify this one. If there are still terms that we can cancel or we can eliminate, we need to eliminate those. So for this one, we will be, for the answer or for the product of the polynomials, you need to write that one into descending order. So that means we'll be writing the highest order first, going to the least exponent or to the least term. So we have 15x to the fourth. We'll be rewriting 15x to the fourth. We'll also be rewriting this one since this is the next highest. So we have 10x cubed. And we also have this one minus 6x cubed. Then there's no other cube in this answer, so we'll proceed with the lower exponent. So we have the positive 10x squared. So we have 10x squared. Then this one, so we have plus 12x squared. And this one as well, so we have minus 4x squared. And the next one is the power of 1 or equivalent to x. So we have 8x. And we also have minus 4x. And the coefficient or the constant of our answer, which is 8. So you just have to write it there. Now, if we can still simplify or we can still eliminate some terms, then it is better or it is really required to simplify those equations or terms. So for this one, since x to the fourth is the only highest power here, so let's just rewrite this one here. So we have 15 x to the fourth. Now 10 minus 6, that is equivalent to positive 4x cubed. 10 plus 12, that is 22, minus 4, that is 18. So that's positive 18x squared. And then for this one, we have 8x minus 4x, so we have positive 4x plus our constant, which is 8. So basically, this is already our final answer since we cannot eliminate any more terms from here, or we cannot simplify this anymore. So this is already the answer for our problem above. So another example we have here, find the quotient of the polynomials 18m raised to 12, n raised to 20 minus 24, m raised to 22, n raised to 15 all over negative 6m raised to 5 and n raised to 10. So basically, in this case, we can apply the laws of exponent. For this one, we can apply the quotient of a power. So as you can see, they has the same base, or they has the same variable with the denominator. So we can just apply the quotient of a power in this example. But as you can see, there is an operation in between there is an operation in between our algebraic expressions. So meaning to say, we can also separate this one. We can also solve this one separately. So that being said, we can rewrite this one as equivalent to 18 m raised to 12 n raised to 20 all over negative 6 m raised to 5 and n raised to 10 minus. But negative divided by negative, that is positive, so we can just rewrite this one as positive. So we have 24 m raised to 22 n raised to 15 all over 6 m raised to 5 and n raised to 10. So basically just copy the denominator. So what we just did here is we just separated the numerator having the same denominator. So performing the quotient of a power under the laws of exponent discussed from the previous video, so we can already find the quotient of this polynomials. So 18 divided by 6, we all know that is equivalent to, since this is negative, so that is equivalent to negative 3. And then m, since the exponent of the numerator has the higher value than the exponent of the denominator, so meaning to say you can just subtract that one. So 12 minus 5, that is 7, so m raised to 7. Now for the value of n, it also has the higher value than the denominator, so meaning to say 20 minus 10, that is equivalent to 10. Now for this one, we can just also have this added to our first expression. So 24 divided by 6, that is equivalent to 4. And m raised to 22 minus m raised to 5, that is equivalent to m raised to 17. And n raised to 15 minus n raised to 10, that is n raised to 5. So basically, this is already our final answer. So we have another example still under the division of polynomials, but in this case, we will be using a different process on solving the polynomials that we have here. Earlier, we used the laws of exponents in solving the division of polynomials. So in this case, we'll be using a long division of finding the quotient of our polynomials. So we have here the example, divide 42c cubed plus 46c squared minus 22c plus 30 by 6c plus 10 using long division. So in this case, we will just be rewriting this one using the format of how we are normally solving long divisions. So basically, this will be our divisor and this will be our dividend. Now rewriting this one, we have 42c cubed plus 46c squared minus 22 C plus 30. And we have to put this one. And this will be our divisor. We have 6C plus 10. Now, in solving this one, we just have to divide the inner or our dividend by our divisor. 42 divided by 6, that is 7. And as you can see, this is just C. So uh, basically, the tip here is how many C is lacking to get the value of cube. So meaning to say C is only 1, so you need 2 to have a cube later on. So we have 42 divided by 6, that is 7C squared. The tip here is if you add this one, if you add the C squared and the C raised to 1, that should be equivalent to the power of the exponent or the exponent of our dividend. Now, multiplying this one, same process, 7 times 6, that is 42. And then C squared times C, that is C cubed. So we have 42C cubed. And then multiplying this one by this, so we have 7 times 10, that is equivalent to 70C squared. Then subtracting this is already equivalent to 0, so there's no need to write this one. 46 minus 70, that is negative 24C squared. I'll just erase this one to avoid confusion. So 24C squared, repeating the same process, we need to divide it by 6C. So we have negative 4. Then how many C is lacking to get the value of 2? So that is only 1 C. So negative 4 times 6, that is negative 24C squared. Then this one again multiplied by 10. So we have negative 40C. Putting this one below, we have negative 22C. Right? We need to put this down. Then we have subtraction. Now, negative 24 minus negative 24, that is already equivalent to 0. So we have negative 22 minus negative 40, that is equivalent to positive 18C. Then repeating the same process, 18 divided by 6, that is equivalent to positive 3. Then C is they already have the same value of the exponent, so there's no need to write the value of C here. Now 3 multiplied again by 6C, that is equivalent to positive 18C. 3 multiplied by 10, that is positive 30. So we have to subtract this one. Now putting our last term here, we have positive 30. 18 minus 18C, that is already 0. 30 minus 30, that is already 0. So basically, we already have our quotient, which is 7C squared minus 4C plus 3. Now we'll move on to another process of solving division of polynomials, which is what we call the synthetic division. So in solving synthetic division, for example, we have here divide 2y raised to 5 minus 2y raised to 4 minus 35y cubed plus 13y squared minus 20y plus 27 by y plus 4 synthetically. So in this case, in solving synthetic division, you just have to rewrite the coefficients of our dividend, which is this one. So you just have to rewrite the coefficients. So for this case, the coefficients that we have is 2, we have negative 2, we have negative 35, We also have positive 13 and the negative 20. Sorry. Uh, we have negative 20 and then we have the positive 27. Now, this is our divisor and divisors are written inside this form. So you have to equate this one into 0. So if you equate this one to 0, we have y is equal to negative 4. So meaning to say our divisor is also negative 4. So that is how we write or how we rewrite a synthetic division before we continue with solving this one. Now afterwards, the process is you just have to bring down the first coefficient. So we have to bring down 2. Now after we bring down our 2, we need to multiply this one. We need to multiply 2 by our divisor, which is negative 4. Now, in this case, 2 multiplied by negative 4, as we all know, that is equivalent to negative 8, right? Now, for this case, you need to write the answer of their multiplication. You need to write the answer of their products in the second line. So, after you write the product of the 2 and negative 4, you need to add this line in the second line. Now, negative 2 plus negative 8, we all know that is equal to negative 10. So basically, the process will be repetitive. So the next process again is multiplying negative 10 by negative 4. So that is equivalent to positive 40, right? Now, after we get the product again, we write it in the second line. And then we perform the addition of these two. Now, negative 35 plus 40, that is equivalent to positive 5. So we'll also again write the sum of the sum of these two numbers here. Now, after we got the sum again, multiply it again with our divisor. 5 times negative 20, that is, I mean 5 times negative 4, that is negative 20. So rewrite that one in the second line. 13 plus negative 20, that is negative 7. Now, negative 7 multiplied by negative 4, that is positive 28. And then negative 20 plus positive 28, that is positive 8. And 8 multiplied by negative 4, that is negative 32. 27 plus negative 32, that is negative 5. So the last term now, the last answer now is our remainder. This one is our remainder. You'll know how. Now, after we got these coefficients now, we will be rewriting this one in an algebraic expression. So that being said, since as you can see, the highest exponent that we have here is 5. After we got the coefficients here, after we got the quotient of our polynomials above, this this exponent, the 5 here, will be reduced by 1. So meaning to say, 2 here will have 2 here is equivalent to y raised to 4. Then this one, this is written as 10 y raised to cube. This one will be written as 5 y squared, negative 7 y, and then we have the positive 8. And then again, this is the remainder. So meaning to say, in writing a remainder, we have negative 5 all over our divisor, which is y plus 4. So this is now our final answer. Okay? I believe those were all the topics that we will be discussing under the operations on polynomials. And I hope you learned something new from this video. And I'll see you on the next video.